So, buongiorno, salam alaikum, good morning to all the guests and to their excellencies, Ambassador Lehner and President Al-Ababi. And welcome to this webinar on space exploration and Earth observation, organized in the framework of the Innovitaly UAE initiative. I would like to begin mentioning that my institution, the New York University Abu Dhabi, is active on the topics of this webinar and is collaborating with the UAE Space Agency, the Mohammed bin Rashid Space Center, and Khalifa University, all part of today's event. By the way, precisely during this week, my collaborators are assembling the payload of a mini satellite with the help of a small Italian high-tech firm, and I think that Professor Marpu will mention the specific project later on. I would also like to add that the idea of that satellite was born some years ago during the internship of two Emirati students at the Italian Space Agency, also a guest of the webinar. So for all these reasons and connections and collaborations, I'm especially honored to be here today. So now I would like to ask Ambassador Lehner to take the floor.
Thank you very much. Thank you, Professor. I am very thankful to everybody for being here today. This is actually the second webinar that we are organizing within the framework, as you said, of Innovitaly UAE, an initiative aimed at exploring the opportunities of bilateral cooperation in highly innovative sectors, bilateral cooperation between Italy and UAE. We are convinced that there is much to do in highly innovative sectors between our countries, and we are here actually to highlight the opportunities. I mean, in this format, virtually today, we are, how can I say, we are going to carry out a sort of scoping exercise of our potential cooperation, and then hopefully will be a meeting in person. We are thinking to organize a sort of space day, hopefully early next year, as soon as the situation allows us to meet in person. Well, space, of course, is one of the most promising sectors for our cooperation. Italy has been a pioneer in this sector. Most of you know that we've been one of the first countries in sending a satellite into space in '64, thanks to the team led by scientist Manlio Broglio. So, I mean, we are talking about, a long-standing activity. To go, to count the last day, week, September 25th, Italy was the first European country to join the Artemis program, which is, how can I say, quite an important initiative to renew the exploration not only to the moon, but also from the moon to the other planets, and hopefully to Mars. Well, I don't want to highlight, the main records that, our space exploration and Earth observation, has earned, but I prefer to highlight, on the other hand, the importance of our partner, the UAE, within the Arab world and, I'll say, globally. UAE is the only Arab nation with an established space agency. We have today Director General, His Excellency Al-Ababi, and I'm very thankful to him, as I'm very thankful to Professor Saccocia, President of Italian Space Agency. UAE has a Mars program, quite far-sighted. We're talking about the 2117 Mars program, with the objective to take the man to the moon by that horizon. And UAE has been the first Arab country to send a probe to Mars this year, and we are seeing that in these days the probe Hope is halfway to Mars. The first Arab astronaut to access and to participate in a program in the International Space Agency is an Emirati. So I mean, many records, and UAE has also been a lead at regional level. I like to remind the project of Satellite 813, which also because I mean, it's something I can say very, I mean, poetic as well in this number, in this name, because it reminds to us the year of establishment of the House of Wisdom in Baghdad, so a sort of golden era and a golden age that UAE, with I mean, its capabilities, energy, its vision towards the future, I mean, is keen to, how can I say, relaunch in the current time. So there is scope for I mean, huge cooperation between our countries. There's already a memorandum of understanding in place that we are keen to implement, dating back from 2016. So there's much to do. And it's important, I think, to have this event, this webinar in these days, in this week. This week, as you know, is the World Space Week. But it's also the week in which we are celebrating the Expo Space Week. You know, Expo Dubai 2020 has been postponed to next year, but we are in these days we are actually having some of events, a sort of preparation to the Expo according to the different themes that I mean will be launched and developed within Expo 2020 Dubai. And a number of events have been organized within this initiative, and we would like to connect today's webinar, ideally to also the Expo Space Week. We are, as Italy, planning to have how can I say, a focus, a specific focus on space within our participation at 2020 within our pavilion. In order to illustrate, I mean, our capabilities and our contribution to space exploration and observation. That said, I don't want to say more. I want to take more of your time, and I leave back the floor to Professor Anello for moderating the panel. Thank you so much.
Thank you, Ambassador. So now I would like to introduce the first speaker of the webinar, President of the Italian Space Agency, Giorgio Saccoccia. Thank you for participating. The floor is yours.
Thank you very much. Can you hear me well?
Yes, we do.
Okay. So good morning, everybody. My regards to my colleague head of agency, Ababi, and all the participants. I have a presentation to share. Let's see if I can put it on the screen, or someone can do it for me. Let me see. Can you see it?
Yes.
Can you see it on the screen?
Your screen. Yes.
Is it in full screen mode? Can you see it well?
Yes, now it's in screen.
Oh, okay, great. Mode. Very good. So, yeah, the intention of this presentation indeed is to talk a bit about what Italy is doing in the subject of this webinar, specifically about space exploration and Earth observation. And I think the best way to start this the dialogue of today is to show a picture that is somehow bringing together our two countries and what space can do. Why our two countries? Of course, it's a picture of Abu Dhabi, and what you can see is a landmark. It's the Ferrari Center. So we have Italy and the Emirates together, and and the high from space that bring us closer. I think the idea is to show that there is already quite a strong, very strong link between our two countries in space activities. There are all the conditions, in my opinion, to strengthen those links in the future. Of course, there is an excellent relation at agency level. We are already aware that our industries are talking. There is a strong dialogue talking about both small enterprises and larger groups, and later on Luigi Pasquali and Massimo Comparini will certainly talk about that. I think we can just enter into a next stage of collaboration for interests that we would like to share. But just to summarize quickly what Italy is doing in the field, we have a very long tradition in the field of space. Goes back in time to the 60s when we launched our first satellite. We were the third country to launch a satellite, and what we have built up over the years is an excellent, I would say, an important network between, of course, institutions, government, industries, and our academy and research. This brought us basically to the current situation. Italy is, I think, one of the few countries in the world that operate in all the space sector, all the space field of application, from access to space to all the fields of application of satellites, the important so-called mid and downstream, so all the services that basically constitute what we like to call today the new space economy. We have a large industrial base for more or less 250 companies. We have about 7,000 employees operating in different ways in the space sectors, a large footprint of small and medium enterprises. You can get a lot of information on the current industrial geographic distribution, say industrial distribution, in a publication that you can get also online, which is the Italian Space Industry Catalog, where I think our potential international partners can have a very important insight on what our industry is capable to do. It can do also with other countries. Just a few words about how the importance to space activities translates into the political support. Since a couple of years, the governance, the space governance in Italy report directly to the Prime Minister through a ministerial committee constituted by 12 ministries plus the Conference of the Italian Regions. This is just to show how we strongly believe that space is permeating all the sectors of society. Therefore, cannot be just one ministry in charge of space activities. Well, okay, I will skip this, but of course we have our own strategic vision, which of course permeate all the sectors of the Italian society, and also regulate our interaction with other countries through what we like to call space diplomacy. And this is just to show you, because it's very much related to what is the subject of today's webinar. We have a number of strategic lines defined directly by our Prime Minister, and clearly Earth observation is one of the first one, together with all the aspects of exploration, both robotic and human. And this, of course, to be pursued in isolation, say, as a strategic asset for our country, but also in strong collaboration with potential international partners. Going specifically to Earth observation, I think we have a long tradition in this field, which led us to the capability to build important assets, in some cases unique in the world. You see here a picture of some of our assets I will mention in a second. In particular, we can take advantage since a few years of an important constellation of satellite which make use of radar technology to explore, to look at Earth in every condition, days and night. No problem about the clouds. You don't have this problem anyhow in your country, we know, but in other places on Earth, there might be situation where we have to look through clouds, and for this reason, the Cosmos Skymet program, the constellation, at the moment we have 5 satellites orbiting the Earth, provide essential data that we use for civil, but also defense application for security. The application, okay, I'll go quick on this. The application of the Cosmos SkyMed constellation has an incredibly wide footprint of services, which goes from risk monitoring and the management of emergencies, monitoring of environment-related aspects like ocean, ice, etc. Something that for us, of course, is very important is the monitoring of what's happening to our coasts and the water inside our mainland. Forestry, support agriculture. I mean, simple, so-called simple information linked to Europe planning and cartography, and a lot of scientific application as well. We are quite proud of the way we use this important asset, which is in continuous evolution, because we are at the moment building new satellites with an intention to continuously update and replenish the capability of this constellation. Of course, as you can imagine, we use the data not just for our own interest, but we make use of the data of Cosmos SkyMed through also commercial partners, and Luigi Pasquali will certainly say something about that. We offer these also to other countries and potential partners almost everywhere in the world. You remember the picture I showed at the beginning? This is the same picture taken by Cosmos SkyMed at night. So you can see that it's quite a formidable instruments to perform observation in every condition. We make use of Cosmos SkyMed, as I mentioned before, also as part of collaboration with other countries, sharing the use of our constellation with satellite built by other countries. For example, here you can see an example of a collaboration between us and Argentina, which make use of our Cosmos SkyMed and the SAOCOM satellite that they have recently launched. This is just to give you an idea of possibilities and opportunities to collaborate with other countries, not just exchanging the final results of our satellites, the data, but also possibly putting together resources on a system-of-system type of approach. In addition to Cosmos SkyMed, last year we have launched quite an innovative satellite which is called Prisma, which is a satellite which operates in the so-called hyperspectral range. And this is quite a first at the moment in the world, and is capable to provide information, important information in particular on the materials, of the essence of the materials that we are observing. And this is a fundamental instrument to support subject like air quality, pollution level of what you are observing, etc. Another example of collaboration we have with the Israeli Space Agency because they will launch a similar satellite in the future that we jointly develop, and we can of course put together the two satellites to perform joint observation. I mentioned before the fact that in Earth observation, Earth observation is the core of new space economy today. So it is not just important to launch our satellites, but it's also essential to enable commercial products that will make use of the data that these satellites produce. What you see here are examples of what the Egeos company, which is a collaboration between Telespazio and the Italian Space Agency, can do to provide services to a very wide scope of end users. And this is something that, of course, we can immediately offer already now to United Arab Emirates in case there is an interest for a specific application. Moving to exploration of the universe, we have a very, very long tradition of contributing to robotic mission, scientific mission, not just with the European Space Agency, but also with other partners, of course, NASA, JAXA, and for us, science really has no borders. So we are totally open for collaboration on to share data of our own missions, or maybe to work, if that's the case, and if it is offered, on data coming from mission from other countries. Specifically for the field of robotic exploration, that we know is of great interest for you, we have more than 2 decades of contribution to the largest international scientific mission. You see here some example of what you're doing at the moment for, in particular for the ExoMars program, and what we plan to do in the future on other missions. What I want to stress here is that we're not just talking about the important role of prime contractors for satellites or probes, but also I think we have quite an excellence status in the production of key technologies that our industry has developed over the years. I'm talking about capability of drilling on other planets, specific scientific sensors, etc. So once again, we are totally open for collaboration, and also to transfer, if the condition apply, this knowledge to potential partner outside. Moving to human exploration, I think we have can be particularly proud of what we've built up over the years, because I think Italy has today is one of the few countries in the world that has the capability to support to contribute to the life support of astronauts outside our planet. Because just to remind you, more than 50% of the western part of the space of the living modules, say habitability modules on the space station, has been manufactured and developed in Italy, and this has enabled us not just the opportunity to work on purely governmental, say, initiative, but also it has opened a door for commercial initiatives. It's not by chance that the expertise developed by our industry to build the modules for the space station has given us the opportunity to develop many other elements of the overall system of the International Space Station, including commercial supply, collaboration on commercial supply logistic modules that you can see here, the Cygnus, that is developed together with Orbital. Of course, this important effort dedicated to the human exploration has given us the opportunity also to have our astronauts, Italian astronauts, on board the space station, and not just via the normal, say, share that we would have of the flight time through the European Space Agency, but also thanks to bilateral collaboration directly with NASA. This is, of course, put us in the position to be a partner for whatever other international initiative there will be in the future. First of all, it has been mentioned already by the ambassador before, the important Project Artemis that the United States is pursuing to go back to the moon, to stay on the moon in a more sustainable way, and to use this project as a starting point for further exploration toward Mars. We are again government, agency, and industry working together to offer our capability and expertise of the whole, basically, Italian industry to collaborate in a strong way to the Artemis program, not just via ESA, but also again in direct collaboration with America. I think we are basically getting very close to my presentation, because what you can see here is just again a long list of all the contributions that we have had so far, and what we propose, what we think we can do as a contribution to Artemis. We are talking about different elements already where we are already contributing. I just want to remind you that at the last ministerial conference, Italy of ESA, Italy contributed strongly to the exploration program, and very recently our industry, Thales Space, won the contract to develop the so-called iHub, which is the first large habitation module for the Lunar Gateway. And now, again, TAS is the only non-American partner of the three contenders for the first lunar lander, and of course we all cross the fingers that the consortium where TAS belong to, led by Dynetics, will be the final winner, which means that there will be an important part of Italy landing for the first time on the moon after 51 years. Okay, it will be 53 at the time. So just to finish, I would like to remind that we talk about large programs, important assets, but Italy has also a very strong competence in mini, micro, and nanosats, which is, of course, the new way today. In particular, what you see here is an example of a national platform, so-called Platino. Is a platform in the class of 300 kilograms, developed by Consortium of Industry in Italy. And this is a multi-purpose mission, multi-purpose platform that will host, depending on the type of mission, different type of payloads, and can easily, in my opinion, this can certainly easily be offered for collaboration with other countries. It's a high-performance platform which makes use of sophisticated technologies to make it even more performant, like electric propulsion, etc. So, my instinct would be that this could be an interesting way to start talking about possible collaboration for joint interest. But of course, we are open to whatever opportunity might arise. So. Sorry if maybe I've been a bit too long, but I think it was important to set the scene for further discussion. And of course, we are extremely open to discussing possible future collaboration.
Thank you, President Sacoccia. Very impressive presentation, very impressive portfolio of activities and projects. And so now we move here to UAE. We'd like to introduce Hamad Al-Marzouki, Project Manager of the Emirates Lunar Mission of the Mohammed bin Rashid Space Center. Hamad, the floor is yours.
Thank you, Francisco. I would like to present So thank you very much for giving me this opportunity to talk about mission. My name is Hamad Al-Marzouki. I'm the project manager of the Emirates Lunar Mission. Throughout this presentation, I will go through Mars 2117 and how is our mission linked to that strategic program. Then I will talk briefly about the mission objectives, the initial concept design of the rover, what are the scientific areas of interest, and how we are going to implement those interests. And then I will talk briefly about the landing site selection process. So, Emirates Lunar Mission is part of a long strategic goal set by UAE government, which is called Mars 2117. This is a very ambitious program where it intends to set human settlement on Mars by 2117. In order to do that, a lot of technologies has to be developed and advanced, and a lot of challenges there. And In order to do that, from our perspective, we thought that we need to identify what are the challenges and to start to tackle those challenges one at a time. And today, and since the announcement of the MS Lunar mission, we think that, and being part of this ambitious program, we think that the MS Lunar mission will try to solve one of the challenges and will try to advance UAE's capabilities in robotic technology exploration. And that is one of the technologies that will allow us, hopefully in the future, to achieve the Mars 2117 objective. However, in order to do that, we started with identifying what is the international strategy in future exploration, and we went by the Global Exploration Roadmap, and we identified 4 points set by the Global Exploration Roadmap in order to advance human exploration to Mars and to the solar system. And we identified 2 key points that our mission can be linked to the Global Exploration Roadmap. Definitely, it's a lunar mission, and the Global Exploration Roadmap has set the moon as a platform for advancing human capabilities and technologies in order to further explore the solar system. And we identified that 2 key points that our mission is in line with the Global Exploration, which are the technology demonstration and having high frequency, cost effective explorations. So the objectives of the mission, primarily, as I stated earlier, is that we want to advance UAE's capabilities and technologies in robotic explorations. But if we are going to the moon, then it will be interesting to do some useful and interesting science there. So as a secondary objective, we would like to contribute to the science community by generating useful data from the lunar surface. Definitely, we have some extended objectives. We would like to attempt to survive lunar night. We have some interesting ideas that we would like to explore in order to do that. And also, we would like to engage the public more in our operations as one of the objectives of the mission. This is an initial concept design of the rover. You will see that it's a 4-wheeled rover that is designed to overcome obstacles of 10 centimeters and to drive over slopes of 20 degrees, and has two communication systems, primary and secondary, and has 2 main cameras. One camera that is mounted on an armed gimbal system, and also one that is on the back. Also, it has 3 main science instruments called CAM-M, CAM-T, and Langmuir probe, and I will talk about them in a minute. And also, we identify one experiment that is called MAD, and I will talk about that in a minute as well. So those are the scientific areas of interest that we identified in our mission. When we started defining the science interests, we identified what are the knowledge gaps that has been identified for the moon and also for future technology explorations. And we identified the scientific areas of interest into 3 categories. First, we would like to do petrography and to understand the geology of the moon. Second, we would like to understand the lunar surface plasma conditions. And finally, we would like to advance future mission technologies. And all those interests and those objectives are implemented through different instruments. First, before going deeply into those instruments, I will talk about the 2 main cameras. So we have 2 main cameras. One camera that is mounted on an arm with the gimbal that will give this camera a wide field of view around the surrounds of the rover, and this is a 4 megapixel camera. And we have also another camera that is mounted on the back, also will be used as a backup and also for reverse driving. Those cameras, those are high resolution cameras, will be used for navigation and to produce high resolution imagery of the lunar surface. And since we are targeting an area that has not been explored before, we believe that whatever images will be produced by those images will be substantially add value to the science community in order to understand more the geology of the lunar surface. In addition, we have a thermal imager. That thermal imager will allow us to provide thermal data of the lunar surface. And since currently most of the data available about the moon and the characteristic of the thermal characteristic of the lunar surface are generated through orbiters, our instrument will provide fine-grain, high-resolution thermal data to as an addition to the available data from orbit, and that we believe that will refine our understanding of the thermal characteristic of the lunar surface. The lunar surface, the thermal characteristic of the lunar has extreme conditions where it varies from minus 180 or 170 degrees Celsius up to 100 degrees. So those extreme variations need to be understood better in order to have a safer future human exploration of the moon. One interesting instrument that we have is a microscope imager. This imager will be mounted on the front part of the rover and angled toward the ground. And this instrument will allow us to resolve particles of the lunar regolith down to 50 microns, and that will provide valuable data to the science community in order to understand the composition and the particle distribution of the lunar regolith. Lunar regolith and its characteristics is one of the key challenges for either human missions and also for robotic missions in the future. We have seen that, for example, in Apollo missions, the astronaut suits were completely covered by the lunar dust, and scientists believe that the reason for that is having the lunar regolith as a fine dust, and that helps it stick easily to the astronaut suit. So it's important to understand the characteristics of the lunar regolith in order to make sure that we advance technologies for future human exploration and also for robotic missions. One of exciting and interesting physical phenomena that has been observed and has been modeled is where an electron sheath is forming on the lunar surface with the day and night, and that phenomenon makes particles of the lunar regolith travel between locations, and also it makes some particles of the lunar regolith to levitate. This phenomenon has been only modeled. There were no ground truth measurements in order to understand this phenomena better. And our instrument, we have a unique instrument that will be sent to the lunar surface for the first time, which is called the Langmuir probe, will measure the electric charge on the lunar surface from different locations at different times of the day. And that will allow us to provide data in order to refine those models and to understand this phenomena better. This phenomena also contributes highly, as scientists think that this phenomena contributed highly to the stickiness of the lunar regolith on the astronauts' suits during Apollo missions. Also, we have an interesting experiment that we would like to do in order to advance future missions, which is an experiment where we want to experiment with different materials that will be stuck on different parts of the wheels, and those materials have been selected carefully to have certain characteristics in order to protect against lunar regolith. And the idea is that we will stick those materials and we'll drive in different locations and see how those materials are effective against protection against the lunar regolith. This is an idea, and we believe that a lot of science cases similar to this one can be generated with the mobility feature of our rover and with the high-resolution cameras that we have on the rover. Finally, I will conclude this presentation with what are the criteria that we are looking into in order to select the landing site. Definitely, as I mentioned, we would like to explore new areas that has not been explored during previous missions. And we have set some, and also it has to have some interesting features that can be explored through our science instruments. However, we have also some criteria that we have set to have no slopes bigger than 15 degrees, to have distribution of boulders less than 30 centimeters of height, and it definitely will be near side of the moon, and we are targeting, as you can see on this figure, we are targeting mid-latitude locations. We have been through this process since a couple of months, and we have down selected interesting locations, and we have a short list of 5 landing sites, and we plan to select a primary location and a backup one in case of an emergency. Thank you very much, and we'll be happy to answer any question if you have.
Thank you, Ahmed, for this very impressive presentation on this fantastic project. There was a question actually in the Q&A about who is going to build the lander.
So we are negotiating currently with different potential partners. We have already at an advanced stage with the potential landers, and we will disclose the conclusion of these discussions in the coming months or next year by maximum.
Thank you again. So now we move to the next speaker, and I'd like to give the floor to Hessa Al-Matroushi, Deputy Project Manager for Science Section of the Emirates Mars Mission. Floor is yours.
Thank you so much. I'm sharing my slides. Can everyone see it?
Yes.
All right, so this is Hessa. I'm the Science Deputy Project Manager for the Emirates Mars Mission, and I'm here to present an overview of the mission and its objectives and the status of it. So beginning from 2014, the UAE government has announced the Emirates Mars Mission with 4 main objectives as pillars. So the first objective in mind for the government that we're using this mission to complete Mars orbit insertion by UAE's 50th anniversary in 2021. So that takes place in December 2021. The second one is to use this mission to develop UAE scientific capabilities, and even from the engineering side and research side, and to contribute to the development overall of the science and technology sector in the United Arab Emirates. And we would like, even through this mission, to increase Emirati's contribution to the scientific community. And by that, to bring in novel science that complement the UAE and the international community when it comes to Mars science. So with these objectives in mind, the mission was developed through 6 years to be launched in 2020, since we have only one opportunity every 2 years to launch to Mars. So we can be there by the deadline that was given by the government by 2021. So we defined a selection of scientific objectives for the mission, and we looked into several factors. We wanted to have the mission as unique. We provide scientific valued data that would be able to complement the existing science when it comes to Mars. So the Emirates Mars mission will be looking and focusing on the Martian atmosphere of Mars. We will be looking into different layers, and we do have 3 scientific objectives. The first one looks specifically into the lower atmosphere of Mars, where we'd be measuring the surface temperature, atmospheric temperature, the dust, the water vapor, ozone, and even the clouds that are in the Martian atmosphere. This is to understand the climate of Mars and the variation that happens day by day and even seasons throughout the whole Martian year. The second objective is to connect these conditions and variabilities in the lower atmosphere with those that happens in the upper atmosphere of Mars. And we would like to look more into the escape rates that happens in the exosphere of Mars. And this is objective C of the Emirates Mars mission, where we'd be able to characterize the exosphere and look in specific to the hydrogen and oxygen escape and try to link it with the lower atmosphere through objective B. So this is how the Emirates Mars mission was formed and developed to achieve these 3 scientific objectives. The Emirates Mars mission is not the first mission to study the Martian atmosphere. However, it's unique by its scientific developments. We are the only mission that will provide a global geographic coverage of the Martian atmosphere with local time coverage as well. So we're covering diurnal and even subseasonal timescales, allowing a detailed assessment of the Martian atmosphere throughout the different layers that it has. We have a very unique orbit that no mission had flew to before. So our orbit dimension is very huge compared to the others, as you can see in the image ahead. We have a dimension of 20,000 kilometers by 43,000 kilometers. But this orbit is what allows the Emirates Mars mission to get its unique science. We're able to look at all the different layers up to the exosphere of Mars. We're able to look at the geographic coverage of Mars as a whole at the same time and look at different times. This was limited by other missions because of the orbits that they have. So each orbit will cover 55 hours, which is approximately 2.24 salts. We have 3 scientific instruments on board of HOPE probe in the Emirates Mars mission. The first one is Emirates Mars Infrared Spectrometer called EMIRS. This is a thermal instrument that will look mostly into the temperature and different constituents in the lower atmosphere. And then we have EXI, which is Emirates Exploration Imager. This is an imager that has a channel of visible wavelength and even UV wavelength, and it will be complementing EMIRS and looking into the lower atmosphere of Mars. And then we have the third instrument, which is Emirates Mars Ultraviolet Spectrometer called EMUSE. This is an ultraviolet spectrometer, FUV1, that will look mostly into the upper atmosphere of Mars. So in the thermosphere, we'll be looking into the oxygen and the carbon monoxide, and in the exosphere, we'll be focusing on the hydrogen and oxygen specifically for the escape. This is how the HOPE probe looks like. This is our spacecraft. So its dimension is around 3 meters by 8 meters, having the panels open, and its wet mass is 1,500 kilograms. So the HOPE probe was launched this year in the summer, in July 2020, and this probe and all the scientific team is a result of international collaboration. So we have the UAE Space Agency funding the project, and we have Mohammed bin Rashid Space Center taking into action the development of the project with 3 key partners from the United States. We have Laboratory for Atmospheric and Space Physics, part of University of Colorado Boulder. We have Arizona State University and Space Sciences Lab in UC Berkeley. We have even a more broader scientific team that encompasses members from all these institutions, in addition to Space Science Institute in the United States, LMD from France, and even more. We have even our launch partner, MHI from Japan, which launched the HOPE probe into space this year. Looking at the timeline, as I mentioned, we started back in 2014, and the development lasted for only 6 years. And this is in comparison with missions of similar magnitude is very short time, because they take maybe 10 years or more to do that. But we were tied with, and we were aiming for a launch and an arrival for the orbiter before the 50th anniversary of UAE. And that's why we had such short development timeline, which we planned our milestones accordingly to make sure that we launch on time, which we did in July 20 at 1:58 a.m. UAE time. The HOPE probe launched, and up to now it completed around 80 days in space, traveling more than 200 million kilometers. We're looking to an arrival time of February 2021 next year, where we will have our Mars orbit insertion. And then we will have a couple of months to calibrate the instrumentations and make sure that they're calibrated well to give us the scientific data products that we need. And then we will start our science phase that will last for 2 Earth years to make sure, which is equivalent to 1 Martian year. So we have an idea of capturing the whole dynamics of the Martian atmosphere in all its season throughout a full Martian year. And I would like to end by talking about the data that the Emirates Mars mission will get. So the science phase is planned to start in May 2021, and the first data release would be just 4 months after that to the whole public and community that is interested to analyze the data. It will be in September 2021. And then after that, every 3 months, the data will be updated in a website called Emirates Mars Mission Science Data Center. This website will provide data access for everyone, quick looks, and even visualization tools to be able to analyze the data on the fly. It will have free access. Only people interested will have to create free accounts. And then the data which will be available there would be level 2 and more, which is those calibrated data and the scientific products from the mission itself. And I'm open to any questions, as we're excited to reach Mars by next year to be able to tap into the data and do exciting science with it.
Thank you. Thank you so much, Dr. Al-Matroushi, for this wonderful presentation. I have a question myself. Do you have any indication now on the status of the instruments during the flight?
Yes. So during, we're currently in the cruise phase. So we have a lot of cruise activities that we conduct, and we test the instruments in, and we calibrate them to make sure that they are functioning well, along with the spacecraft as well.
Perfect. Thank you. Congratulations on this wonderful project.
Thank you.
So now we go again to Italy. I would like to give the floor to Giuseppe Arridon, the chairman of the Space Committee of the Italian Industries Federation for Aerospace, Defense and Security. Floor is yours.
Thank you so much, Professor Arneodo. Let me thank the Ambassador Lehner for having invited us, IAD, to this panel, and let me welcome all the distinguished guests and friends here. And just a few words just to framework what IAD is within the Confindustria system of Italy, Confindustria being the main association representing all the manufacturing service company, all the various economic sectors. And within Confindustria, IAD is the federation which groups all the Italian enterprises active in aerospace, defense, and security. So it's a huge, let me say, and a very technologically relevant group of companies, grouping more than 60,000 employees, and with an overall turnover of in excess of 16 billion euros in 2019. So it's with a very big players being part of this system. We remember Leonardo Group with Fincantieri, but also companies like Iveco, Avio, Aero, Elettronica, and so on. Not only big groups, because over 80% of the associates of the IAD are SMEs, and bringing a rich portfolio of competence and technologies. And this is overall. But this is also true in particular in space. And in space, IAD gathers almost 85% today of the Italian industry in terms of average, in terms of headcounts and the turnover. And this percentage is going to increase as we are in the process of regrouping the different associations that in Italy are grouping space industries. In particular, within this year, also the Association of Space Application and Services will converge into AIAD, so the representation will be even richer, just for the sake of bringing the instance of industry to the table of the Italian ecosystem in space, which is very rich, as Professor Sacoccia pointed out, and he already described the governance part of it and the plans and implementation and the policy part of it, which Space Agency is part of. Of course, the research centers and university are part of this system, but also the industry. We consider ourselves being an essential stakeholder for implementing all that we have seen in the presentation of Professor Sacoccia, being a strong element of heritage and which is long-standing in the field from the part of Italy. Italy has promoted a huge number of groundbreaking missions. And there's, I would say, a natural inclination to partnership in space. It has been the promoter and the member of many international collaborations on a bilateral and a multilateral level. And this is something which is in the let me say, in the genetic part of our heritage, and we are, we said, one of the few countries that can bring to this cooperation a very rich and full scope of activities and capabilities covering the complete value chain of the space activity, from the upstream to the midstream to the downstream, as has been already underlined, with some specific area of excellence in some technologies that have been mentioned, that of course the peculiarity and the excellence in the radar field, talking about observation, has been mentioned. The chemistry, the capability to go into the chemistry of what we observe through the hyperspectral is another feature that is worth to be exploited so much in many applications, not only in the commercial field, but also in particular in the defense and intelligence and security field. And we are a very rich sector in Italy in this space, with more than 250 companies, which are really bringing a huge variety of technologies and very innovative capabilities to the implementation of new concepts and new ideas, which are part of the new space. And let me recall that there are important programs being launched in this new space. Framework that Italy has been one of the first countries to push, also through the Italian Space Economy National Plan, which is now being implemented, at which industry is really proud to be part of, supporting many of the initiatives that are being launched. So basically, what do we think our role may be in this partnership framework? We would like to be, let me say, a gateway to foster and to support all the technology and industrial interest that from the UAE space community could be brought into the table, that we would like to, let me say, feed in a two-way street cooperation, just fostering whatever initiative could come up. And there are many fields in which I think that the opportunities could materialize. Some of them have already been spotted in the presentation of Professor Sacoccia. We have two national champions here, Thales Alenia Space and Telespazio. I'm sure that in their presentation they will mention other specific and potential area of cooperation. So thank you again, and this concludes my brief presentation of AIID.
Many thanks for your presentation. And now we step in the academic world, and we have Professor Sean Sway, Director of the Khalifa University Space Technology and Innovation Center. Sean, the floor is yours.
Okay, so I'd like to first of all thank for your kind invitations, and I'd like to share my screen. So I'm going to go ahead and share my screen. Just bear with me. Okay, just hold on. Let me see. Okay. Can you see my slides?
Yes.
Okay, great. So my name is Sean Sway. I'm the professor of practice in aerospace engineering at California University, also the director of the Space Technology Innovation Center. This is my great honor and a pleasure to have this opportunity to showcase the center, COOSTIC. COOSTIC was launched fairly recently in June this year. And it attributes to the collaborative work of UAE Space Agency, Yahsat, which is Al Yats Satellite Communication Company, and Khalifa University. So there are three parties, and there were some signing of agreements. So COOSTIC is, I think, in terms of role and responsibilities, Space Agency is providing funding for research projects, administrating support for research projects, and also supporting external collaborations. And us, KU, is to execute and monitor the research projects, and YASA is to provide technical management support for the CubeSat projects particularly, and the internship opportunity for students, and also supporting the external collaborations. So these are really, three parties having this, common synergy and common goal to enhance and promote the space effort, especially enhancing the space technology in UAE. Okay. I'd like to briefly give you an organization chart here. The center has actually identified 8 research thrust areas that were led by the university faculty, as you can see, across multiple disciplines. And these thrust area includes collaboration with existing KU centers. For example, if you're talking about the communication, satellite communications, then we are actually linked with the Center for Cyber Physical Systems, C2PS. And in the area of space robotics, it leveraged the KU's autonomous and robotic systems. So these are, areas where we would like to further develop and also solicit some of the research efforts from the communities. So these are the list of UAE Space Agency funded projects. We have ongoing CubeSat effort that has been going on. I think Dr. Prashant, he's going to talk about it a little later, that he's going to elaborate about a number of interesting CubeSat effort that has been embarked within the California University with the support of YASAP and also Space Agency in UAE. And the project also, also support, the Space Agency also support the space robotics and also the next generation's antenna systems and also space battery. So these are the very niche area where a lot of discussion and effort has gone into to identify those topics. So these are the topics that we Acoustic, the center is going to be taking into charge in terms of executing, soliciting the proposals, and in terms of reaching out for the experts in the area, and have them to come up on board and to support us and collaborate with us. So I'm going to show you some potential collaborative research subject that we are actually soliciting. So these are some of the area, not just limited this area, but nonetheless these are the area that we're actually taking a closer look now. But any other area in terms of space technology, enhancement and exploration, I think we have open-minded absolutely to have further discussion. So the first one is the space robotics. The project's primary objectives are to develop cost-effective robotic systems to provide continuous monitoring of deployed or constructed assets on both lunar or Mars orbit or lunar Mars service. So this includes, for example, the 2 areas that we're actually particularly interested in looking into tele-delayed issues, because whenever that you have a telecommunication, there are some delays, and how do you actually deal with those delays and still be able to effectively, commanding the rovers. And secondly, another kind of a, equally important focus that we're trying to develop is to build up the so-called micro rover. Okay, we are talking about maybe 5 kilogram or less rover that can actually do a lot of surveillance, a lot of these scouting, those tasks on the surface of Mars or Moon. So this project is actually led by Professor Lakhno and Professor Hore of PUCAS. And I would like to maybe talk about the next one is the next generation antenna systems. This project focuses on developing a small form factor advanced antenna design concept by utilizing the 3D metal printing and intelligent machine learning algorithms. The objective, the goal is to develop the future lightweight antennas that is optimally tailored for planned space missions. This project is actually led by and co-led by Dr. Muhammad and Dr. Prashant and Dr. Khalid. And as far as the space battery is concerned, it has been, we all know that, battery is one of the critical technological bottlenecks, not just for the space application, but also for the electric cars, or for the emerging, urban air mobility vehicle like, flying taxis. So this is really, kind of a very timing, but we do know that the investment has to continue, the research has to continue. So the goal is really to develop space-rated, efficient, high specific energy lithium-ion battery for space and other commercial applications. And this particular project is actually led by Dr. Daniel Choi. And next, I would like to talk about, although this is kind of beyond the scope of what space agencies support, but we think that this is something that we have to build in-house and to proactively anticipate to see that there's something that is going to impact us in the future. So the sustainable astronomy in the era of large satellite constellation, quite frankly, is not far away. It's looking at how SpaceX been, laying their satellites. It is expected that it's going to be clustered the space. So in a way that we are trying to what the BI trying to actually focusing on is in fact to trying to address the future observational astronomy challenges due to the presence of many small satellites in low Earth orbit. Okay, so as you can see from this on the figure on the right, this is a picture taken. You can see from the figure that the satellite, the bunch of a satellite is actually, producing very feasible trails that occupies substantial fractions of field of view in observations. So if we were to do, I'm not an astronomer myself, but I can see their pain that there in the future, there is going to be a lot of disturbance, a lot of noise. To them, a lot of this low Earth orbit satellite is going to be a noise. So how do we actually, so this presence not only impact the scientific capability for the future observation, but also disrupt the effort to detect and monitor near Earth objects which are susceptible to colliding with the planet Earth. Okay, so the objective of this project is to develop an automated system, advanced automated system to predict and schedule astronomical targets so that to minimize the impact of the observation. So this project is led by Dr. Elena Fantino of Acoustics. And lastly, I would like to maybe touch upon this robotic in-space assembly of a large space structure. This in-space assembly, quite frankly, is a key to construct large or ultra-large space infrastructure, such as if you're talking about the kilometer-long, kilometer-wide solar panel substructures or communication antenna subsystems. And this is something that we foreseen in the future that this would be a great platform for us to actually engage. The objective of this project is to utilize advanced digital composite metal materials and the discrete construction approach to robotically build ultralight space structure with arbitrary geometry and arbitrary dimensions. So when I say discrete construction approach, you can see this as a Lego approach, meaning that you have many same parts, but very small number of distinct type of parts. Okay, and this project is led and co-led by myself and Dr. Yaya and Dr. Hore. So if you have anything that you like to have a follow-on discussions or would like to have a further questions to be answered, please don't hesitate to let me know. And my contact is shown here. And again, I thank you all for your time and for your kind invitations. Thank you very much. I'm signing off.
Thank you.
Thank you.
Thank you, Professor Sway. And there is actually a quick question, but you signed
Oh,
off.
I'm sorry. You would like to see the?
No, sorry, you're there. Sorry, so there is a quick question on the Q&A. If in your center you have the capabilities to study shielding, radiation hardening, or you're seeking out external collaboration on that.
This is a capability that we are actually building a lot of in-house capability. And one of the things that we're actually building up, of course, for all the space related effort is building up the heritage. And in order to actually build up the heritage, definitely you would like to also have the ability to study and build up the shielding capability. So, and absolutely, that is one area where we could definitely, look for collaborations. And of course, there are other areas where we are really open for discussions and collaborations.
Thank you again.
Thank you.
So the next speaker is always in the academic world. So Professor Prashant Marpu, manager of the YASAT Space Lab. Prashant, floor is yours.
Thanks, Francesco. So I'll not have any slides, but I'll briefly mention what we are doing at the YASAT Space Lab. YASAT Space Lab is now part of Khalifa University Space Technology and Innovation Center, which Sean was talking about. This lab was established way back in 2015 with the support of YASAT. That's why we named it YASAT Space Lab. Over the last 4 years, we've been largely working on education programs where we established a graduate level education program with the integration of CubeSat development into the curriculum. So with that, the students participated in 4 satellite projects till now. MySat-1, which was an educational satellite, but at the same time, we developed a camera system based on quartz components and qualified that in space. And we also tested a small coin cell battery based on novel lithium-ion technology, which was developed at KU. The extension of that is basically what is going on till now with the Space Agency funded project, which Sean was mentioning. We hope to test more advanced batteries in the future satellites like that. MySat-1 was a very good successful project. It worked very well for a decent time, like 6 months, and then it went silent. 15 months later, last week, exactly as we are talking now, it suddenly woke up and started sending beacons. That was amazing. I don't know what happened there in between, but we are now studying what's going on with that satellite, and it seems to be very healthy all of a sudden. We are looking into that. Then we extended MySat-1 with MySat-2, which is MySat-1 was a 1U satellite, 10 centimeter by 10 centimeter by 10 centimeters. Now we have a 2-unit satellite, MySat-2, where we said, let's start doing something on our own now. Education is going hand in hand with development activities where students are also working on thesis along with the participation in satellite projects. So in MySat-2, what we're doing is we are developing our own attitude control library. We're not developing the hardware yet, but we're developing our own attitude control library. And we're also enhancing the camera system that we developed for MySat-1. So let's hope, if it works, basically we'll have a very compact camera system that can achieve up to 10 meters spatial resolution in a small form factor that can go into a 1U or a 2U satellite. Then MySat-2 is expected to launch in February on the external Cygnus platform, which goes to the space station. It will not be launched from the space station, but it will be launched when the Cygnus vehicle undocks from the space station and goes up to an altitude of 450 kilometers. So this is expected to launch in February. In meanwhile, last 10 days ago, we had a launch of MESSENSAT satellite. MESSENSAT was a 3U satellite developed in collaboration between Khalifa University and American University of Ras Al Khaimah, where KU was responsible for training the students at AURAC and also working with them on defining the science objectives, defining the science payload. And now we'll also take care of the operations and science data analytics part moving forward. It was a very successful collaborative project between the universities and was funded by the agency that opened up ways to show how universities should work together in this domain. It was launched last week. Everything seems to be fine as of now. We are downlinking the telemetry, looks okay. This week we'll be commissioning the attitude control system, and then hopefully in 2 weeks' time we'll start the science operations with that. Then we have this very interesting collaboration with New York University Abu Dhabi, where Francesco is leading that initiative from NYU side, where the physics team at NYU is actually developing advanced gamma ray detectors for detection of harmful radiation from lightning strikes. So we did not expect this to be a complicated payload when we started, but then as we move forward, things started becoming more complicated. We initially thought we could do it in a 2U satellite. As we move forward, we said, this is not going to happen. So we had to move to a 3U satellite, even stretching things, because the payloads itself are extremely sensitive and also power hungry. And to fit something like that in a small form factor is extremely tricky, but we managed things. And there were so many challenges in terms of development of the payload itself. We are doing everything from scratch. A nice collaboration actually that happened through this project, where we went through the space qualification process, and things are being assembled, as Francesco mentioned at the beginning of the webinar. They're being assembled right now as we talk. Hopefully they'll be integrated into the bus in the coming weeks. And the launch is expected in August next year, because then we'll go through the qualification of the satellite in the next period and ship it to JAXA, who will integrate it in their pod and then send it for launch with SpaceX to the space station as a cargo. It will be deployed from the Kibo arm of the space station in August, hopefully, August-September period, basically. So these are some of the projects that we're working on. You see now, at the YASAT Space Lab, it was established to support the education program at the university, but we intend to slightly become more of a center of excellence, working on collaborations with different universities. So we aim to be a center of excellence for designing and development satellites, while also working on with the other universities, other agencies to support their development activities to develop advanced payloads, like the example we had with NYU-80, for instance, and continue working in that direction. While doing that thing at the university through the thesis projects of students, we're also trying to build our own heritage. Like we started with the attitude control software development. Now we started with the camera development. Now hopefully we'll start initiatives on development of our own attitude control system hardware, now that Sean is on board. That's his expertise. We started working on development of our own electrical power system, qualifying the batteries. We learned a lot on how to qualify batteries for space applications through our earlier satellites. We are going through that phases now. Comms systems based on software-defined radios. Then we're also trying to focus on development of readouts. Now, not the entire camera system, not the telescope part, but at least on the sensor part, because largely due to the advances in camera systems for phones, smartphones basically, there's so many better sensors now compared to what it was a decade ago or 5 years ago. So there's so many novel sensors that are coming out into the market, commercially available. So we're trying to see if we can actually develop readouts and be ready for some of those advanced systems, like 40 megapixel cameras or even 100 megapixel cameras now. This is an initiative which started recently, but this is ongoing, and we expect to continue with that work, along with development of FPGA-based systems as well. So these are some of the initiatives we are working on right now, and hopefully we'll continue with the formation of the new space center at KU. This is going to be better organized now, there'll be better outreach as well from now on, because YASAT Space Lab did not have a better outreach till now. We were doing a lot of projects. Now we have a proper website where we can track the progress and so on. Hopefully in the coming period, basically we'll establish a few more collaborations with other universities and expect to do a bit more complicated satellite projects as well, starting with the next project that is funded by the UAE Space Agency. We still did not decide on the mission objective, but that's something students are working on now to decide on their mission concept by December, and we'll initiate that project in January. Thank you, Francesco. If you have any questions, I'm happy to answer.
Thank you, Prashant. This is an impressive lineup of activities. Congratulations. And well, I think that, as you said, the collaborations among universities is very nice, and I personally hope that our collaboration will go on. And so best of luck to all the projects we have in the pipeline. So the next speaker, we go again. We come back to Italy again, and we have the Chief Executive Officer of Telespazio, which is one of the main telecommunications company for space. Luigi Pasquali, the floor is yours. We don't hear you.
Sorry, I was muted. Thank you. Good morning, everyone. Thank you for having invited us to this webinar. So I will go faster because I understand that we are a little bit exceeding our time, but I want to enter into the framework that Professor Saccoccia has depicted at the beginning, referring to the Italian positioning and the capabilities in the space field. Of course, today, focusing on Earth observation and exploration. But just first of all, I would like to introduce ourselves. I mean, Telespazio is part of an international agreement between two large industrial aerospace groups, which are the Italian Leonardo and the French Thales. It's a joint venture controlled by Leonardo. And by the way, the sister joint venture of Thales Alenia Space, which will be the next speaker, Massimo Comparini. And then Telespazio, in this arrangement of Space Alliance, controls as a mission to contribute in the system development, specifically for the ground segment technologies. And then downstream, I mean, operations of satellites, maintenance and operating conditions of systems, but also downstream. Downstream refers, of course, historically to the satellite communications, as you have introduced myself, referring to the telecommunication component, which is definitely the long heritage of Telespazio. But also what we call geoinformation, meaning Earth observation applications, which are today a very important component of our activities. In this field of geoinformation, downstream, we have built up a dedicated subsidiary company, which is called eGeos, together with the Italian Space Agency. And the goal of these eGeos, this happened 10 years ago. The goal of these eGeos is to offer to the market specifically applications based on satellite Earth observation data. eGeos and Telespazio through eGeos is already among the three major service providers at global level. And then, of course, we are looking to continue in this path of being a global provider. This concept of global refers not only to geography, it refers mainly to the capability to use the largest variety of data in a way to enrich our applications. And then, of course, the main reference of satellite data refers to Cosmos Skymed, who was introduced by Professor Saccoccia as a very important satellite constellation, Italian satellite constellations dual system based on SAR radar technology, which with all the benefits that radar can bring, that we all share in terms of observation, you know, all weather and all time. Cosmos Skymed is definitely a key element of this evolution of Telespazio and Geos, but Saccoccia has also referred to the hyperspectral that we have launched last year in Italy through Prisma, and other collaborations which allow us to integrate a large variety of data, like the Argentinian L-band SAR of CIASG, or Copernicus ESA satellites, or many others. By the way, of course, the optical data, which are the most traditional elements of Earth observation, are very much also used in different ways based on international collaborations that we have established. So globality in terms of capability to serve applications with data, but also globality in terms of geography. We are today basically offering our services in all the continents, and this is definitely a platform of collaborations. And before exploring a little bit more this concept of collaborations, which is one of the topics maybe very interesting for this kind of conversation of today, I want also to remember another directions which are essential for our downstream in Earth observation evolution, which is the large use of digital technologies that we have developed in the last years, of course, starting from data analytics and big data and cloud solutions. By the way, in this field, we have recently announced a specific marketplace, which is called Cleos. And Cleos is a digital marketplace where partners and customers may access to data, to applications, to solutions that we have already developed, but they also may develop themselves additional applications based on their own requirements and using our data and our solutions. So it is a very innovative possibility to enlarge our business, but also to enlarge, again, collaborations in this field. Of course, we have in the trajectory to improve these digital capabilities, looking, for instance, to have by the end of the year, as a group, as Leonardo Group, we will have available under development in this moment a high-power computer, which will improve tremendously our process capability in this field, and also we are injecting in our applications artificial intelligence solutions, which are increasing effectiveness of the results. I said applications, so then I need Professor Saccoccia has already mentioned, but I would like to stress that there are some specific vertical fields where we work and we have developed, and we are continuously developing our global presence as applications. Most important, very important, of course, is defense and intelligence. But then we have emergency, where we provide solutions also at the European Commission level, but to cover a global level, the support to emergency based on Earth observation systems, agriculture, cartography, maritime, stability, climate change. These are the main, but of course, other are arriving based on specific requirements that we can capture from the field. So then I want to restore the point of collaborations. Collaboration is one of the ingredients that we are using, because Telespazio is a multinational company based in 8 countries, mainly Europe and Latin America. But also, basically, we look to, as I said, the global presence, not only on the commercial dimension, but also on the partnerships. By the way, we as a Telespazio are working already with Yasat, mainly in the field of satellite because of Thuraya, because of specific communications for defense, and the KA satellite systems for broadband access. But of course, we have in this dialogue, we are also looking to develop some possible collaborations also on Earth observation, because, as I said, is definitely one driver where we can bring expertise and knowledge and experience, but we can get the powerful of the developments that we have also heard are under evolution in the UAE. Before to close my speech, I want to make a reference also to exploration, because this is the second subject of the today discussion. And I like to see that there is an important project specifically for the moon. It's very important also the one for Mars, but I'm referring to the moon for a specific reason, because Telespazio today is answering to a call of the European Space Agency, supported by the Italian Space Agency, to develop an operator which will be able to build up an infrastructure on the moon for communication and navigation, and then to operate that infrastructure to serve whoever wants to go to the moon to make some specific operations, like the one that has been described during this webinar. Well, we are proposing to ESA to be one of the prime possible in Europe for this specific project. Of course, it will be a matter of a process which will last a couple of years, but at the end of that, we will be either driving or be part of a consortium which will operate services on the moon. So then this can be another element of an important discussion with the UAE trajectories in space. Finally, I want to remember also that in Europe we have, under the umbrella of the European Space Agency, we are developing a project which is called the Space Rider, for the capability to make a flight suborbital with the autonomy of landing back to the Earth. This is something that Thales Alenia Space is developing as a manufacturer and technology industry, but Telespazio is also supporting because of the ground system control for the mission. And then, in perspective, together with the Italian Space Agency, we would like to open a service profile based on this suborbital flight, because it can be a place to develop specific experiments and projects that can be very interesting for whoever partners in the world, and the UAE for sure is more than welcome eventually. And we as Telespazio will control the missions of this service evolution. So I've been very fast, but just to list a little bit which are the key ingredients of our trajectory in Earth observation and exploration. And based on that ingredients, we are ready to foster our dialogue with Emirates and its industry. Thank you.
Many thanks, Mr. Pasquali, for this. Certainly a lot of opportunities for collaborations at the highest level. And now let me invite the Deputy Chief Executive Officer of the Thales Alenia Space, Massimo Claudio Comparini. Floor is yours.
Thank you, Francesco. Thank you for the kind invitation. Honestly, I settled a brief presentation, but I understand we are a little bit out of time, so I will send to you, Francesco, to relay it to our colleagues and friends, and I will go through the logic quite fast, and of course taking also reference of what Giorgio Saccoccia said and also Luigi just before me. We know that space technologies and space infrastructure are really kind of pervasive technologies today, from the low Earth orbit, so from the study of our planet, how to have a sustainable planet, to observe what is going on the Earth, and I will spend a few words on that. To the low orbit, so I mean the environment where in the last couple decades, man was starting to live on the International Space Station, really important for what is our future roadmap. So we understand how to survive in that environment, what we can do, what we can develop in that environment. So the Earth and the low Earth orbit, the closest planet, the moon, so back to the moon in 24, and again, also in this case, how to be close to the planet with a station, with a kind of logistic outpost, and how to go back and forward from this to the moon, to, let's say, to deploy the strategy on the moon exploration, on the moon resource exploitation, and last but not least, of course, how to use that outpost to explore further in the solar system, and of course the roadmap to Mars and to the planet explorations. So just to give an idea of a journey, which is a journey where our sensors, our satellites, our infrastructure are, and where we can learn and we can acquire huge amount of data through the human presence, or also through robotics and robotic missions. Earth observation. So to observe the planet is fundamental, as I said, to have a sustainable planet. So we have, through a program like Copernicus, which is a flagship of the European Union and the European Space Agency, with a very large contribution of the Italian Space Agency that Giorgio Saccoccia recalled just a few minutes ago. We have been prime of a number of satellites that are flying since years, the Sentinels. You know that we have a kind of specialization in our industrial footprint. So optical technologies are basically more taken by the French colleagues, and radar technologies taken by the Italian colleagues, which is also a kind of element that we take for the export. So when we provide optical satellite and radar satellite to observe the Earth for other purposes, including intelligence and security. And this is, of course, the direct link to Cosmos K-MED, to the Cosmos second generation. So a constellation of 4 high-end synthetic aperture radar, to be honest, with unprecedented and unmatched performance, that we were the prime contractor, and we built since the year 2000, and now we are going to complete the constellation with number 3 and number 4, the launch of the second satellite of the second generation planned next year. So a full spectrum of product and technologies, from sensors and satellite for Earth observation. Just to spend a little bit few words more on the radar technologies, which is peculiar of the Italian part, the company, Cosmos K-MED, Cosmos second generation, so high-end radar, deep submetric, 2 tons machine, just to give you an idea. But Giorgio mentioned as well how we are going to develop specific technologies for smaller satellite to help the construction of a high number of satellite constellations. Platino, it's a kind of mid-class radar, so we are in the class of 250-300 kilos, which is really interesting to have a combination of performances and cost. And then, of course, we are also studying a lower weight. So what we can achieve with a smaller solution, let's say 80 kilo, 100 kilo, again, in order to be able to deploy a high number of satellites with a reasonable budget. Revisit time and spatial resolution are fundamental for the application that Luigi mentioned before. Exploration. it's an amazing and huge domain where I really can say I'm proud that we represent a kind of excellence in the space world with the technologies that we develop and we manufacture in Italy. It's I think it's well known about more than 50% of the pressurized model of the International Space Station has been built in our plants in Turin. The capability to conceive and design a pressurized model, so an habitat where an astronaut may live in a microgravity situation, is long-standing, starting from the first Columbus project many years ago. And now it's not only, of course, the base of what has been built up on the International Space Station, but it's also the base of the Lunar Gateway. Giorgio, remember that we were contracted through the European Space Agency and of course the contribution of the Italian Space Agency to the International Habitat, the more complex pressurized model of the Gateway. We have a role together with the US partner on the logistic model, so a kind of business to business. So we are responsible for the primary infrastructure of the pressurized model of HALO. And we are in another 3 elements of the Gateway: the Esprit, which is a kind of logistic communication model; Orion, the capsule, where we provide our technology as well; and last but not least, the potential landing system, so the system that through a pressurized environment can bring the astronauts back and forward from the Gateway to the Moon and also from the Earth to the Moon. So a big role where we provide our system, our architecture capabilities, as well as all the technologies to build a pressurized model. And I want to mention, I think this is important also in the specific context of this seminar. It's not just us. I mean, with us, we have about 50% of the technologies that coming from small, medium enterprises in the Italian chain, as well as through partnership. So this is fundamental to build up the partnership at institutional, but also at industrial and scientific and academic level. The Moon. Of course, back to the Moon means to understand how we can use our planet, how we can exploit the resources, which means that we need to stay on the planet. Stay on the planet means to have pressurized module as well on the planet, and of course, with all the system to protect from the radiation. So this is the concept of the so-named shelter. So an environment that using our capabilities well proven over the years in orbit, low Earth orbit, Gateway will help the man, will help the astronauts to be there for to secure their mission. Again, it's a kind of base technology that we are going to reuse in a kind of platform-like concept. The shelter, the human landing system, the pressurized environment. Robotics. Personally, I believe that the planet exploration would be a combination of man and robots and robotics missions. We have just moved all the hardware that will leave for the mission ExoMars 2022 from our site in Turin to our site in Cannes to make some final tests. We were together with Giorgio and Luigi a couple of weeks ago there, and it's really amazing see the hardware, the technologies that we install, and with our prime contractorship role for the ExoMars 2022. Again, it's a combination of a set of the enabling technologies to communicate the mechanism, the driller that is provided by Leonardo. I mean the line of business space. So it's the best proof, I think, of our architecture and technology expertise to provide solutions for the planet exploration through robotic mission. This is a part of just a part of our competence skill, because if we go to the solar systems, we have missions and we provide probes, satellite or sensors basically all over the planet with a number of missions Mercury, Saturn, Mars, of course, Jupiter. So there is really a long list of instruments and satellites that would build up. And of course, as you can imagine, it's not just the construction of the hardware, it's really the knowledge about the environment, the knowledge about what does it mean to put a probe in the orbit of those planets and to have measurements. I think one element which is fundamental in our activities has been already briefly mentioned by Luigi, is partnership. Is partnership through, let's say, the enterprise and the industrial scheme, small, medium enterprises, and also new startups are playing already a role, but will play, in my mind, a role in the future, but also partnership across the countries through bilateral and multilateral agreement. It's not by chance that we have the word of space diplomacy. So space, it's really a platform for cooperations. And I really think that through the institutional partnership, through agreement, of course, on our side, through the Italian Space Agency and the Italian government, I think there are really plenty of opportunity of partnership. I was really interested to see some technologies element in the previous presentation, and I really believe that, or through, let's say, technology system like video conference, or really, all of us, we really hope quite soon after this COVID crisis will be over, hopefully leading face to face. There is really plenty of opportunity starting from the enabling technologies. I saw, for instance, some element about CubeSat. It's an element, I mean, a small satellite or macro satellite is an element to build up new infrastructure. For instance, again, Luigi mentioned the role on the service side of Telespazio for lunar communication. We need to build up an infrastructure. Of course, we will be responsible for that on the Italian side. Just an example, through the bilateral with NASA and US administration. We can have different configuration. We can have a data relay satellite bigger to give the capacity, and then federation with the small microsat constellation for positioning and navigation on the planet. So there are really plenty of opportunities, and I really believe that's my the philosophy, my philosophy, and also the shareholders. I really believe that the partnership of a big space industry like we are with the small medium enterprise, with the research institution, academic, it's fundamental, let's say, to cover a so broad range of technology that we are talking about, again, from observing the Earth to explore our universe.
Thank you. Thank you, Massimo. So in the sake of time, I think that we're going directly to the concluding remarks. Any unanswered question in the Q&A will be followed up afterwards. So apologies for the ones whom we could not answer. So I would like now to give the floor to Mohammed Nasser Al-Hababi, Director General of the UAE Space Agency, for the concluding remarks. Director, the floor is yours.
Thank you, Professor Francesco. First, I would like to thank His Excellency Ambassador Nicola for organizing this event. I enjoyed it myself. I learned a lot from both sides, especially from our colleagues and friends in Italy about the space capability and space activities and the potential that both countries can have. I also, would like to thank all the participants who are helping to facilitate and to expand the knowledge and the potential when it comes to space between Italy and United Arab Emirates. I would like to probably, again, for the sake of time, to take this few minutes just to give you an overview of UAE space program. As you might know that, and you learned from a number of talks here, that we have different projects, inspiring projects when it comes to space exploration. We have a mission to Mars. We have also a mission to the moon, astronaut programs, but also we have capabilities in different areas, and when it comes to education, regulations, and space economy. As you might know, that United Arab Emirates has identified space as part of its current and future, because space provide great benefits when it comes to strategic, scientific, economic, and social. We know that space is a great tool to inspire young people towards STEM education, and also a platform for innovation and a perfect model for space diplomacy. Our space program, started a long time ago, but today the landscape is as follows. We have 10 satellites in orbit, ranging from satellite communication to remote sensing to educational satellite. As you heard, the latest one was Mizensat that launched a week or so. We have 3 operators who owns and operates satellites. Yahsat, it's an international satellite communication company that provides services to Middle East, Africa, and even South America. Mohammed bin Rashid Space Research Center makes satellites and also operate remote sensing satellites. We have 4 research space center. One was Shan Sui and Khalifa University, and also Professor Francisco, that we have established the Space Science Center in Abu Dhabi, New York University. We have 3 universities that are providing space education. The country spent around $6 billion so far on space infrastructure. And as you probably know, that we have the first space agency in the region. As I mentioned, the Mars mission, the astronaut program, and also recently the Emirates lunar mission. Not only on that, but basically we are also, when it comes to regulation, we are very active. We are a part of all peaceful policy discussion through United Nations, through different groups. We signed 4 space treaties. We have completed our regulatory framework. We issued our national space policy, national strategy, and also forward-looking law that was issued last year. And also we issued what we call a space investment promotion strategy, where now we focus on space economy. When it comes to, again, international partnership, we do believe that space is all about partnership to lower the risk and also to reduce the cost and speed the accomplishment of a space program. And we are proud that we have already signed a MOU with Italy, and we have already engaged in different discussions about potential space cooperation. And I commend His Excellency the Ambassador, who believes in space, and he is also promoting space through different activities, either meetings or very similar to this webinar. When it comes to space economy, we engage with the different stakeholders within the country and also internationally, try to promote space economy. We think that we have a good space environment when it comes to regulations, when it comes to the ecosystem, if you like. We have a potential of local investors who are interested in space, and now we are try to engage with the different countries, and we are planning also to engage with His Excellency, the President of ASI, to see how can we encourage, space economy, space partnership in both countries. I mean, we, as covered by Hissa and Hamad, when it comes to the moon and also to Mars, I have nothing to add. When it comes to the astronaut program is going well, and the next batches will be selected by the end of the year through Mohammed bin Rashid Space Research Center. We have interesting initiative for the region, actually. United Arab Emirates, took our leadership, took a bold, program to encourage other countries in the region to enter in space program and space activities. And we were mandated by the government as a space agency to establish what we call Arab Space Cooperation Coordination Group. Now we have 14 space agencies and entities from 14 Arab countries coming together, coordinating and integrating their space activities. The headquarters in UAE, and we think this is going to be a cornerstone for future Arab Space Agency. We hope that this can be achieved in the future. Not just only establishing this group, but UAE has announced that it will build a satellite for the Arab region. Both, it's going to be a tool where experts come and participate, but also the satellite will provide services to the region. We are committed to continue our growth of our space program, and with colleagues, people like you, I think we will achieve our goals faster, and we can go further. Again, I would like to thank His Excellency and all the participants for this seminar, and I'm looking forward to engage directly or virtually with various people to promote UAE and Italy space cooperation. And thank you so much for this opportunity. Back to you, Francisco.
Thank you very much, Your Excellency. And now for the final remarks, I give the floor to His Excellency Nicola Lehner, Ambassador of Italy to the UAE. Ambassador.
Thank you very much, Francesco. Thank you. Thank you. I wish to thank again everybody for their insightful presentation. I think that, if the objective of this webinar was to highlight the opportunity of cooperation, I think we have attained it. I learned a lot personally, but I think that everybody learned a lot about the axis of future cooperation. There are really many potential sectors or subsectors in which we can cooperate in services. Hardware, satellites, both relating. Relating, let's say, to both the space exploration and Earth observation. Actually, another sector of cooperation could be also launchers. Somebody mentioned Avio and the Vega launcher, which has been also I can say object of a cooperation between Italy and UAE. I think that on the topics highlighted today and on possibly other ways of cooperation, on this we can move forward and have possibly, as I was mentioning, in-presence event, a space day, a bilateral space day, hopefully next year before Expo 2020, first half of next year. This is our aspiration. So this could be, let's say, a first follow-up. In the meantime, of course, our space agencies are in touch, the industry and the academies are in touch, and the ideas and the projects like today can be further developed bilaterally. So thanks again. Thank you for your presence, your time here. You've been a little bit, maybe longer than expected. I think that there was so much content that this time was needed. Thank you very much again. The next webinar within Innovation with the UAE initiative will be on the 21st of October and will be devoted to smart cities and sustainable mobility. Thanks a lot. Thanks, Francesco, for moderating so efficiently this event. And I look forward to see you again, hopefully in person very soon. Thank you very much. Have a good day.
Thank you.
Thank you.
Thank you, Your Excellency.
Thank you, Ambassador. Thank you for all the guests and all the attendees, and looking forward to the next webinar.
Thank you.
Thank you.
Good day and good weekend to everybody.
Thanks.
Pronto? Ehi, ciao. Un po' più lungo.